to know what happens when we take some products of these. So what happens, for instance, if I first rotate by 240 degrees and then reflect through the right-hand vertex. So this notation that we've got here, we can understand in two ways, or I think we can understand in two ways. In one way, I'm saying first rotate the triangle 240 degrees and then flip it through the mirror line that goes through the right-hand vertex. So in that case, in that interpretation, what this product operation symbol means is really a sort of and then. So do this and then do this. Now the other interpretation is rather than thinking of these symbols, this notation as operations themselves, we start to think of them as objects. So these are sort of 6 different objects. There are 6 different positions of the triangle. And then this operation is some way of combining these 2 objects. So in the same way that with, say, multiplication, we have something like 3 times 5. 3 is a number, 5 is a number. This multiplication symbol is something that takes these 2 numbers and spits out another number. So let's see what, how the spitting out process happens with these guys here. So I'm going to begin by just drawing my original position. So my R0. Okay, so originally that's how my triangle looks. I then rotate 240 degrees. So that brings the triangle to here. Looks like this. And then I take the mirror that goes through the right-hand vertex. So that's this mirror here. It's going to leave C in the same position, and then A and B will swap. It's going to go like this. So A is here, B is here, C is here. And if I look back to my 6 symmetries, I can see that this is MT. So the result of this is MT. So again, with those 2 interpretations, if I rotate the triangle by 240 degrees and then flip it through the mirror that goes through the right-hand vertex, the bottom right-hand vertex, this is the same as just from the beginning flipping through the top vertex. So it would keep the A here, flip through like this. So in that case I get the product of symmetries, rotation of 240 degrees and then taking the mirror, is the same as doing MT. So two symmetries together is, equivalent of taking one single symmetry. With my other interpretation, I say that my result, when I take the R240 object, so this object here, combined with this object here, using this operation, the result is MT. So I take 3, I take 5, when I put them together with this multiplication symbol I get 15. If I take this object and I take this object, I put them together, I get this object. It's the result of taking that operation. Okay, so now my next question is, if we think of these sort of in the same way that we think of multiplication or addition, what happens if I change the order? So if I do MR times R240. Now, with multiplication, we have this property that's known as commutativity. So what commutativity means is just that if you've got, taking the operation between two things, it doesn't matter whether you do 3 times 5 or 5 times 3. The result will be the same. So we're asking the question, if R240 product with MR is equal to MT, is the product of MR and R240 also going to be equal to MT? So let's have a look. Start here. I'm going to do my MR. So MR flips through this vertex here. B stays in the same position because it's on the mirror line. A and C swap. So my first position looks like this. So C is up here, B is here, A is here. I then rotate this 240 degrees. And what happens? I rotate it 240 and I get this. So that's B at the top, A down here and C here. And I can see that looking at my 6 symmetries, I can identify this one as ML. So we get immediately, these aren't the same. If I do the rotation first and then take the mirror, I get MT. If I do the mirror first and then do the rotation, I get ML. So we don't have commutativity with this product operation when we're including mirrors and rotations. You might have noticed when we did the exercise in class with the squares and we only considered the rotations of the squares. In that case, order didn't matter. You can rotate by 90 and then rotate by 180, or do it the other way around, you still just get 270 degrees. But in this case, it seems like order matters. So let's just do one more example, and then you can practice by itself. Let's do a couple of mirrors together. So what happens if I do ML times MR? So I start with my R0 position. It's my original position. The first thing I want to do is reflect through the left-hand vertex. So in that case, C stays in the same position, the A and the B swap. So that will bring it to here. So what's that? B at the top here, A over here, and C stayed in the same position. And then my next step is going to be this MR. So if I now reflect through this vertex, now A will stay in the same spot, and B and C will swap. And we'll see that it's flipped back to the front. I've got C here, B here, A here. I look at my symmetries, I can see that this one is this R120. So interestingly enough, I get that the product of two reflections is equivalent to a rotation. So product of symmetries, if I reflect and then reflect again, this is the same as rotating by 120 degrees. Or I can think of it, in terms of those objects, the product of these two objects is actually one of these objects up here. Whereas if I take the product of any of these two, if I take the product of these two, it'll stay up here. Those things, sort of make it interesting when we have these sort of asymmetric patterns between the operations. So what I recommend is you practice doing basically some diagrams like these. So start at your original position, your ABC, perform an operation, then perform an operation again. You might like to use a prop, a bit of paper, or just practice drawing the diagrams. I think it's much easier to draw the diagrams than to just try and visualize everything in your head. And then complete that table that's in the study guide. Remember that because we don't have commutativity, you need to label which of your operations is the first operation, which operation is the second operation. Then once you've got your completed table, that's sort of like an answer sheet for you. So you can just choose any two at random, say ML and R120, see if you can draw the diagram to work out what it is, and then you can use your checklist to find out that the light's gone off. That's very annoying. Okay, but yeah, so in summary, when you're talking about symmetries, remember that you're talking about either doing one operation and then performing the other one, and this being equivalent to performing a single symmetry operation, or we've sort of got this abstract way of thinking of them as objects themselves between which we can define an operation. So I hope you have fun with those and that you do well on your assignments and on your exam. Have a good week.